Can be YouTube stars today. Write an equation for a circle with radius 16 and center -3, -6. Circle, that's way back, but it's kind of like an ellipse. It's a plus. That's what makes it kind of like an ellipse. And then rather over stuff, it equals r squared. So let's see, x plus 3 squared plus y plus 6 squared equals, so what goes in on the right hand side of this equation? It's trying to bait you into thinking that it's 4. It's not 4 though. The radius is 16. I need to square the radius, whatever 16 times 16 is, which I think is 256. So yeah, they tried to bait you into putting 4 since 16 is a perfect square, but r squared goes on the other side. So a lot of the problems, once you get the hang of today, they go quick if you understand circles, ellipses, and hyperbolas.
Just a question about like the formula. Can you not put like uppercase R? Is there like something that the uppercase R stands for, or are you only supposed to use a lowercase r?
The only uppercase R that I know of we use in calculus. It still means radius, but in calculus a lot of times we have some shapes that look like this.
Yeah.
So the outside radius we use a capital R, and the inside radius we use a little r. But in this problem, if you use an uppercase R, it'd be fine because it's the only R there.
Okay.
And in this problem in calculus, like it'll be obvious that there's 2 R's, so you got to use some different letters. You're welcome. Number 2, write an equation for an ellipse. Okay, so I know what an ellipse looks like. Right, it looks like that. An ellipse will have a plus sign there. Ellipses and circles. With the center, -5, 7, so x plus 5 and y minus 7. Piece together the information here. Horizontal, major axis of length 12. Horizontal, major axis. Okay, so this thing is a left and right orientation, and the major axis is 12 units long. How does that help me, or what does that do for me? What does that mean for the equation? What's that? It means that x is the bigger one. But even apart from who's bigger, major tells me it's bigger. Half of that's 6. So what do I do with the 6? Square it, and then where does it go? Under the x or under the y? Under the x, because it was a left and right thing. So 36 will go under the x stuff. Running out of colors to use. Vertical minor axis. So that's up and down of 6, but I don't want the 6, I want the 3, the half of it. And then what do I do with the 3? Square it, and that was up and down, so that goes under the y. Sort of putting all the pieces together. Number 3, write an equation for an ellipse. So ellipse means plus. vertical major, oh, hold on, ellipses always have the x term first, so I can go ahead and put those in there. Vertical major axis of length 10. So that's up and down. So when you say square it, square what exactly? Yeah, I don't want to square the 10, right? Because 10 was all the way across. That means it was 5 from center to vertex over here. So I square the 5, get 25, and then where does the 25 go? Under the y, because that's an up and down thing. Meant to keep color coding. Okay. Foci at 2, negative 2, plus or minus square root of 21. I think that tells me a lot of information if I'm really paying attention here. What can I get from knowing that that's my foci, or those are my foci? The center, because if I ignore the plus or minus, I get the center. So the center then is at 2, negative 2. So x minus 2 and y plus 2. Okay, piece by piece here. What about that plus or minus square root of 21? What's that? Yeah, I have both things. That's c. So c squared is 21. And then we know that a squared minus b squared equals c squared. But what's the 25? Is it the a or the b? This is one where it does matter. A lot of times we can kind of, it doesn't really matter, but it does matter here. How do you know it's the a? Because it's major. So a squared is 25. B squared we don't know yet. But with a squared minus b squared equals c squared, we can figure out b squared. So b squared is equal to 4. What do you want to do with the 4? So it's okay to square root it, but in the problem, what do you need in the equation? B squared. So you can square root it to get 2, but then you got to square it right back to get 4. So hopefully you save yourself a couple of easy steps. B squared is 4, but B squared is what we need, so I'll just put the 4 under the x. Grace, Isabella, you guys okay?
No. Wait, what is major?
Major just means the longer one. But the fact that it's longer means that it's a squared, not b squared. For an ellipse.
Why are we having this?
That's a good question. So 10 is all the way across, but the distance from center to vertex is a. Like when we're graphing these, and we would say we would go 5 from the center, we'd go 5 up and 5 down. So it's 10 all the way across, but 10's not really the number I need. The number we need is 5. Okay? Grace? That's so good. Number 4. Hyperbole. What does that mean in terms of the equation? That's going to be a minus in there. Right? There's all sorts of partial credit on these because, hey, if you just get the minus, that's worth something. I can't even put the x and y in first because whoever's first determines whether it's up or down. I don't know that yet. So, with the hyperbola, about all I can get is the basic format of this thing. How can I get the center?
From looking at the foci.
Okay, I was going to look at the vertices, but the foci would actually be easier. Because if I ignore the plus or minus, I've got the center. The center should also be in between the two vertices. So I was going to do it that way, but I think I like your way better. The center would be 4, -7. Although I still don't know which one's first.
First, yeah, so it's like...
Well, don't you know, because if you look at the vertex, which one changes goes first?
Mm-hmm. Yep. Which one changes goes first? Samantha's looking at the vertex to see it. Can you see that also looking at the foci?
Mm-hmm.
Yeah, so either way, the y values are changing. So I know this is a up and down hyperbola, so that tells me that the y goes first. Then it tells me the x goes second. So y plus 7, x minus 4. I don't know. I find graphing these helpful, or at least starting to sketch them. 4, -3, 4, -11, and then I can definitely tell that this is up and down. And we found the center was at -7. What can I learn from that? How far is that? And what do I do with it? Okay, it's 4. Square it, we get 16. Why is it going to the y? It's changing up and down. So 16 will go into the y. I don't have any information about left and right, so I can't directly know what goes under x. But we do know that c, not c as in center, but c as in distance to vertex, or distance to foci, is 4 square root of 3. And c squared equals a squared plus b squared. Let's see, 4 square root of 3 squared would be 16 times 3 is 48. And then a squared is 16. B squared is what we're looking for. So b squared is 32. And I don't care what b is, because what I need is b squared, so I can just put 32 under there. Yes.
Why is the a squared minus b squared equals c squared? Like, is it c squared, or is it just, what is that one called? Because the other one's a squared plus b squared equals c squared. So what's the a squared minus b squared?
A squared minus b squared equals c squared for ellipses. For hyperbolas, it's pluses. The sign always changes from the equation to the c squared equation. It's always a different sign. Here it is over here. The ellipse is a plus in the main equation, but a minus in the foci equation. They always have a different sign. All right, why don't you try number 5? You try number 5. You can do this. I would start by sketching out what you know. To me, that helps me see what's happening here. So on the video, I'm going to press pause. So you should press pause and try it, and then come back and see how you did. The length of the minor axis. So that would be the other axis. So what is it? What would we do with this 9? Square rooted. And then with that 3, what would we do? If we were graphing this, what would we do with the 3? and go up and down 3. And so what does that mean the length of our minor axis is? 6. Yeah, probably. I mean, not a ton, because that tests almost everything.
Yeah.
That's too much brain power.
That's a lot of brain power required for that one. You had to. I mean, is there a way to work this problem without coming up with the equation? Maybe, but it just seemed to find the equation, do a rough sketch, and figure it out. Could you have done it without a graph and without the equation? Probably.
Maybe.
But that'd be thinking about a lot of stuff to pull that off. Yes, sir. I do know because I have it, but I don't remember what it is. So I'm not trying to hide it from you. I just don't remember. It is a block day, so it's our excuse to give you a long test, right? Number 6. This one's going to go a little bit quicker if we know what we're looking for. Write the name of the graph of each equation. C for circle, E for ellipse, H for hyperbola. Which do you think will be the easiest to spot? Why do you say that? I agree with you. They have different signs. Yeah. Different signs for what? The square terms. Good. So let's see. X squared and y squared would have different signs. Diff signs. So, I mean, yeah, I guess I could do complete the square for all of this, but I don't want to do that. So I'm just looking for x squared and y squared to have different signs, because that's got to be a hyperbola. So x squared and y squared is having different signs. Looks like A, D, and F. Now, circle and ellipses, the shapes are similar, the equations are similar, so they're going to have the same sign. How do I differentiate between a circle and an ellipse?
It would be the last.
It's not the last term.
The coefficients.
What about the coefficients? You're right.
For circles, it's
For circles, they're the same. Think about if you did complete the square for B. So you moved everything around, you factored out the 2, you half it, square it, add it, and then at the end you're going to divide both sides by whatever that number is over there. Well, you're going to get the same values on bottom if you're doing B, because you'd have a 2 at the top, so they would reduce the same way, which if you're thinking it's an ellipse, fine, but you'd be going up and down the same you're going left and right, which would mean it's not really an ellipse, it's a circle.
Circles, the coefficients would just be the same.
Same coefficient. For circle. Meaning even if they're both negative, because if they're both negative, you could multiply 3 by -1 and fix it. And then ellipses would be same sign but not the same number. Same sign but not the same number. Lastly, number 7. Write an equation for a hyperbola. It's got a minus sign. Right, there's a hyperbola.
So, with this one, would you not be able to find the center from foci?
It's a little bit harder to find the center from the foci on this one.
Like, it's not in order, right? Like,
What do you mean it's not in order?
because doesn't the plus or minus square root of 97 usually go to like this?
No, the plus or minus 97 goes on whichever coordinate you want to change. So, what does that mean? The fact that it's not on the y, it's on the x.
So the x is changing.
The x is changing, so
oh, but it's like the same, so it's like 0.
So let me slow down here, but yes, you guys are right. X is changing, or the X coordinate is changing, which means it's a left and right, which means the X comes first. Now, Samantha, do you know where the center is based on the...
Yeah. It's x squared minus y plus 7 squared.
Yeah, the center would be at 0, -7. And so you could just leave 0 as x squared up there, but if you want to be, I don't know, obnoxious or clear, you could put x minus 0 there. Let's see, the vertices are 4, -7 and -4, -7. So how far is it from the center to a vertex? Let's see, the center is at 0, -7. We could put this on a graph if we wanted to. So how far is it from the center to a vertex? 4. Vertex, vertex, center. So that's 4. What do we do with that 4? Square it and put it where?
Under the x.
Why under the x?
That's all that's changing.
Because that's the one that's changing. That's the left and right values, so that 16 will go under the x. Under the y, I don't have any information like on the up and down like for the box, so I can't say exactly what b squared is. But they told me about foci. So little c is square root of 97. A squared plus b squared equals c squared. 16 plus b squared equals 97. B squared 81. Square root it if you want to, but you're then just going to have to square it right back because I want b squared in the formula, or in the equation. So kind of tricky today, but man, when you get the hang of these, then you're really prepared. You have a really good understanding of all the shapes that you can do today. So today is a great review. Tomorrow's the official review, but this is a really good review. We'll review tomorrow. We'll test on Thursday, and everything will be due on Thursday.